You hear the rumble of the exhaust on this Caddy? Of course you don't, it's electric. Most systems on today's cars are electrical, and that's what this show's all about. No fear when it comes to electricity and electrical check on today's Tech Garage. Welcome to Tech Garage, presented by Advance Auto Parts. Well, we got our electric Caddy in the shop. All that's left is I'm going to go ahead and plug it in and get it charging. And that's what today's all about, electrical systems and electrical checks. And a little bit later, we're going to give you some strategy-based diagnosis as we tackle a horn problem. But before we get started, it looks like we got a delivery from Advance. What you got for us, Justin?
Your electrical and your meter you needed.
Perfect, thank you so much.
Yes, sir.
And we'll use this stuff a little bit later. You know, your best friend should be a good parts person. We need to start out with the basics. Now, when we talk about electricity, we have to understand electrical movement. We got to go back to physics class for a minute. You remember those atoms, neutrons, protons? Well, this is a good example. If I spin this around, we're dealing with these electrons in the outer orbit ring. That's going to be electrical movement. And what happens? I put a little pressure from a battery, and it pushes against this one. It knocks him off. He jumps over and knocks the next guy off. That's electrical movement. But if those electrons are 4 or less in the outer orbit ring, well, that makes a good conductor. It allows electricity to flow. If it's 8 or more, they're packed real tightly, that's a good insulator like this rubber right here. And there's 3 terms I want to look at: voltage, amperage, and resistance. Now, voltage, our battery is a voltage maker. Potential difference, electromotive force. Just pressure, but see, nothing's going on, but the pressure's in there. Well, if I turn on the headlights, that's amperage. Amperage is running through the wires now. Remember that electron? He's jumping off, he's running through, and he's going in these light bulbs, which are resistance. It's a form of work. That's what's happening here. Wiper motors, door lock solenoids, all resistance, all motors, all going to use electricity. One other term I want to talk about: electromagnetism. Electricity and magnetism put together. Cars use all kinds of components that rely on electromagnetism. And I got a demonstrator right here, and I'll hook this up. What this does is, I put the positive there, and I put the negative right there, and you can see it's pushing that wire out. There's lines of flux going right there. Well, that's electromagnetism at work. What happens when we put some voltage to our door lock solenoid? Bam, electromagnetism, unlock and lock. Our injectors, electromagnetism, opening and closing the pintle here. Starter motors, same thing. I got a little simulator here I can show you. What happens when I hook it up? It spins around. Those electrical poles are pushing and pushing and pushing and pulling. What's going on there? Starter motor, spinning. Window motors, wiper motors. Well, that's a good look at the basics, but you know, Justin brought our meter, and what we can do is hook it up next and make some electrical checks. Well, let's put that voltmeter into practice that Justin brought us. Voltmeter sitting right here. We can look at the voltmeter, and the first setting on the voltmeter is V with the wavy sign. That's AC voltage. Now, that's in your house, but cars also use it on some wheel speed sensors, Hall effect switches. That's AC voltage. Most of our cars are DC voltage, direct voltage. And I can show you a couple measurements. We can go right across the battery and measure DC volts. This one's at 12.62, or you can measure voltage at a point. I can touch the ground and go to any one of those points, and that'll measure voltage also. Now, the next thing on the meter is resistance, the omega, the horseshoe. This is resistance. Now, cars have resistance values, different components do. This is an injector. You remember those windings earlier when we talked about electromagnetism? Well, that pulls up and down on the pinto inside, and those windings will actually have a specification. So if I go across with no power supply connected, and I read that, it's 12.2 ohms of resistance. Now, resistance is good, but I don't like to use it on heavy circuits. We'll look at later voltage drop, and I'll show you a good example why. If I go across this cable right here, this cable's brand new and it's in good shape. And you can see I have 0.1, 0.2 ohms of resistance here. Now, if I take this cable, what do you think the ohms of resistance would be on this? Well, if I go from the top to the bottom, it's the same, 0.1 and 0.2. But remember those electrons? They're not going to make it through this wire on a starting circuit. Voltage drop's a better way to go. The last one I want to show you is amps. This is AC amps and this is DC amps. But before you measure amperage, you have to shunt your meter. Well, what does that mean? I'm going to take the lead and I'm going to put it over here. There's a fuse inside of here that protects it because we want to measure amps in series. Those little electrons are going to run through the meter and he's going to count them. So what I want to do is I want to come up and I got to open the circuit. I don't want to go parallel, I want to go in series. So I'm going to open up the circuit and I'm going to go from here to where the power starts. Now the light bulb's burning. Now those little electrons are running through and he's counting them. It's 2.1, 2.3 amps of electricity to run that light bulb. You know it takes 6.28 billion of those electrons running through the circuit to create 1 amp of electricity. Well, cars use different types of circuits. We're going to look at 3 of them when we come back with more Tech Garage presented by Advance Auto Parts.
When using a DVOM, how do you measure current flow in a circuit? A. Place the lead across the circuit. B. Place the leads in series with the circuit. C. Place one lead on the positive side and the other on the negative side. Or D. Place the lead across the component with the power disconnected. The correct answer is B. Current flow is measured in amps. Always shunt your meter and place your leads in series with the circuit being checked. This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by Standard Motor Products. When OE fails, trust SMP brands. ARP, the world leader in fastener technology. Dayco Products, keeping you moving since 1905. And by Advance Auto Parts. Let's get you back to the garage.
Welcome back to Tech Garage. Well, there's 3 types of circuits I want to take a look at. And what better way to do it than lay them all out on a board? And cars employ all these circuits. The first one we'll look at, that's a series circuit. That's really simple. I'll come over here and hook up the battery. And you can see our lights are burning. It just comes down, it goes through one light bulb, and then in series, it goes through the other light bulb. Now this circuit, if I unplug one of them, it goes out. The next one though is a parallel circuit. So if I hook that one up, you can see the electricity's coming through and then it divides through both. And the neat part is the 12 volts go through each one of those branches to light the light bulbs. If I pull out one light bulb, the other one stays lit. Good analogy is a good set of Christmas lights. When you pull one bulb out, you can see it, you can replace it. If you have them in series and one light bulb goes out, they all go out. The last circuit here is a series parallel. And what makes it a series parallel is the switch here, I have a dimmer switch, is in series, and then the parallel legs. Once again, if I pull a light bulb out, the other one stays lit. But the series portion here, if I dial my dial down, it goes off, or I can dim them a little bit. But I can turn them both off because it's in series. And I have it right here on the MotoLogic. Professional techs use this. This is a schematic, and we like to read schematics from the top and work our way down. The fuse starts right here at the top of the page, and then it works down through the fuse headlamp switch, just like our board, our switch. This is the series portion. You come down to the bottom of the page, and you have the courtesy lights. If I pull one of the bulbs out, just like you saw, the rest of them are going to stay lit.
And now the email question of the week, presented by Advance Auto Parts.
John, I've got an email question here from Devin in Mobile, Alabama. Devin's brake lights keep failing. He's replaced a blown fuse several times. Now he says this primarily happens when he's towing his boat. Well, recently his friend towed the boat and didn't have any problem at all. Devin thinks it's something in his truck and not the boat trailer. What's your advice for Devin?
Brian, if Devin backs his boat trailer up like you and I, you know, you back up, bam, I'm there. Well, he very well could be pinching a wire on his trailer harness here. And every time he does that, he's blowing a fuse. Well, we need to look at some circuit protection, and we're actually going to short some circuits so you can see what's going on. The first one I want to look at here, this is a fuse circuit. Now, my fuse circuit just comes around. So if I connect this from positive to negative, you can see it's burning. And I'm going to go ahead and I'm going to short it. I'm going to short it over here from this directly over to ground. That would be a direct short. And when I do that, this fuse is going to pop. It's going to blow. Watch this. That's it. circuit's not operational anymore. When you think about a short, there's two types. There's copper to copper, wire to wire. That could feed different components. And then think about copper to steel, something where it's grounding. Those electrons are running so fast that they're going to either blow a circuit or a fuse. This next one's a circuit breaker. Now my circuit breaker, if I hook this up, that's a resettable device. So I can come over here and I can go across the lead right here, and then I can go over here, and when I short it out, what's going to happen is those electrons are going to run so fast, the circuit breaker is going to open. Now, if I let it cool down, they come back on. So what's happening inside that circuit breaker? Electrons are running, it's getting hot. Once it cools down, it comes back. Electric seats, window motors, sometimes you run them, they get hot. I can show you one. I got the circuit breaker right here. And what's happening, those electrons are running so fast that it's bending this bimetallic strip in here and it's opening the circuit. Once it cools, it closes the circuit. Now the last one I want to look at over here, this is an actual fusible link. Now a fusible link is 4 wire gauges smaller than the wire it's protecting. Now you can see the lights are burning right now. My fusible link's right here. Remember, wire gauges, the higher the number, the smaller the wire. So if you have a circuit with about a 10 gauge wire, you want to put a 14 gauge or bigger to protect it. And that's why I have such a big wire right here, because we're going to let the electrons flow through this wire, short the circuit, and my fusible link will burn open and the circuit won't work anymore. And there it goes. Well, you know, we'll be right back with more Tech Garage right after the smoke clears. Welcome back to Tech Garage, presented by Advance Auto Parts. Well, I want to show you how to measure some unwanted resistance on some high amp circuits called voltage drop. We looked at earlier these 2 wires, and I think you can understand now that this wire here is not going to carry a lot of amps, and it's going to turn into that fusible link we just saw burn. We'll measure voltage drops on this motor here with this actual live starter, and what we can do is our first voltage drop can go across the positive cable, that's your battery, and then you're going to come all the way over to the terminal that starts our starter. That's the start wire. Then I'm going to take these jumper wire, I'm going to go ahead and run it, and when I run it, we're going to go to DC volts, and we're going to look for the voltage drop. We'll see what it is. About 0.2. That's good. We don't want any more than 0.5. But what we did is we measured the whole circuit. Perhaps you just want to measure the solenoid. Well, then I take my positive and I go from the top of the solenoid to the starter, and we do the same thing. We got 12 volts there, but when it connects, you can see we have about 0.2 there. Now what's going on inside that solenoid, as you can see these 2 terminals right here, well, when I push that contact button, it's making a contact. If this was loose, unwanted resistance. If this was burnt anywhere, unwanted resistance. That's going to cause low cranking on a starter system. It may cause a fuel pump to run slow and create heat. That's damaging your components. Now there's one more I want to show you, and that's on the ground side. I can come over here and go to the ground side, and then go to the ground on the starter. Just as important, the starter has to ground in order for those electrons to get home back to the battery. Let me go ahead and run it and see what we have. Got about 0.3, that's fine. You don't want more than a ½ volt drop, because you start adding them up and you end up dropping 1 or 2 volts and you're gonna have issues with the components. Now what causes voltage drop? Well, bad wiring. You can see this one here is all connected nice, and this one has some frayed, it didn't make it in there. Well, electricity is like water. If it doesn't flow through there, it's going to cause that voltage drop. Also, heat. Heat is a big factor for resistance. If you get some wires up close to the exhaust manifold or your headers, maybe that's the reason why it's cranking over slow, because the heat's causing that unwanted resistance. Voltage drop will find that. The type of wires. Well, this is great for your house, but it's not flexible on a vehicle. This could cause unwanted resistance. The length of the wire. Well, you run it back to an amp in a trunk, use that big wire that goes back there. Number 1, it's got to carry all the amps. And number 2, you don't want to roll it up in a big winding, because that's going to cause unwanted resistance. Keep your wiring practices good, and we'll look at doing a few of them next. You ever run out of gas when your gas gauge says full? It could be the wiring, or it could just be the sending unit. But I have it right here, and you can see as I sweep it, it goes from empty and it goes to full. This is a variable resistor. It's the same thing the sending unit is, and I have the sending unit right here. Now this is located in your gas tank, and this float goes up and down with your fuel. And if I move it, you can actually see the resistance changing. So what's happening as the resistance change, that's a voltage drop. The voltage that has to go through it is going to change, and that's going to move the gauge. Now you can also use resistance to check a light bulb. And I'm going to change out my leads here so we can take this light bulb and we can check it. Now, this light bulb's blown on one element. You can see the little black in there, and the other element's in good shape. So I'm going to go across here, one of the terminals there to ground. And when I touch that, I have a resistance value. So that element's intact. Now it's important to have good wire practices. We saw the resistance and we saw it in the form of wire. So you want to make sure that you take your wire and use the proper tools. The shrink wrap here, this is beautiful because it's crimped, it's shrink wrapped, and it's even soldered. You can pick up a kit like this that has all the connectors in it. You want to find a wire stripper that fits the wire you're doing, and then also a wire crimper here. There's some shrink wrap that you can put on there, and with a lighter or a torch you can shrink it down, stopping the resistance from getting in there. Get you some quality wire. One more tip, if you're wiring on an automotive vehicle or copper, you want to use rosin core solder. Acid core solder, well that's for the house, that's for plumbing. Rosin core solder, and get you a torch. You know, we got it all covered, but we need to put all this in practice now, and we'll do that when we return with more Tech Garage presented by Advance Auto Parts.
This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by AC Pro. Do-it-yourself AC recharge for cars and trucks. Stage 8, the world's best locking fastener. Hypertech, the world leader in high-performance engine tuning products. And by Advance Auto Parts. Let's get you back to the garage.
Welcome back to Tech Garage. Well, we got our pickup truck in here, and the pickup truck has a horn issue that we need to dive in and fix. But before we do, I want to talk about a term called strategy-based diagnosis. Strategy-based diagnosis is a systematic plan to your work. I'll give you an analogy. Everybody's taking a tire off. Well, you put the lug nuts on the ground, you put them in the hubcap, but you don't chuck them across the shop and look for them later. Well, we don't want to go under the hood and just start poking on wires when we don't even know what we're poking on. So the first step is always verify the concern. This one, the horns aren't working, so we push the horn pad, turn the steering wheel to the left or right, pushed it in all positions, and we can't get the horn to beep. So what we had to do is gather our resources. Look for a schematic. Well, MotoLogic has a schematic, and professional techs use that. So this is where we need to start. At the top of the page of the schematic, there's battery, a battery voltage we're going to need to beep the horns. Then it goes through a relay. Well, a relay is nothing more than a switch. And then on the right side over here, you can see both horns. Both horns are on the whole right side, and come down to the bottom of the page and you can see these two grounds. Well, they're grounded individually, so it's not very likely that both horns are ungrounded using strategy-based diagnosis. Now we come over to the left side and I start dropping down. You can see here, I come all the way down to the horn switch. That's inside the car. That's what we were pushing on earlier to see if the horns beeped. And then you come up, parallel is a body control module. Well, a body control module's teed in because if you lock and unlock the doors, it's going to blow the horn. Well, what we need to do is always, with a good electrical diagnosis, is we need to go ahead and check the fuse, and we can do that right here. Now, the first fuse we want to look at, I got my panel out here, and it says number 30 is the horn. I looked at the location, and I found number 30. So I'm going to go ahead and pull out number 30, which is right here. And some fuses, well, you may not be able to see if it's good or bad. Remember that ohms of resistance? It's a perfect time to use it. I'm going to switch my meter to ohms and go across the fuse. And when I go across the fuse, we have some resistance, we have some continuity. That means that the fuse is intact. We're going to have to go to our next step in the strategy-based diagnosing. Now the next step is to go back to the schematic. Our fuse is good, so what that means is that now our power supply is good. We know we got it all the way down here, and then we tried to beep the horn. So what we can do is, I noticed that that body control module was hooked up in parallel. Those circuits earlier, parallel, it's teed in with it. So we can try it with the key fob and see if that's going to work. and that's working. So what does that tell us? Strategy-based diagnosis. Remember, everything on the right side of the schematic is in good shape. The power's good, the horn grounds are good because they worked. Our problem lies somewhere below that body control module, and that's the switch. Now the horn switch is located inside the truck, and that's where we need to go next. Well, we determined the problem lies inside the truck. So here we are at our horn pad. But when I looked at the horn pad, I saw it's an airbag, and you need to throw up a big warning right there. We went ahead and disabled our fuse, and we waited at a minimum of 10 minutes for the capacitor to discharge because you have to follow all safety precautions when you're dealing with an airbag. Then what I can do is I can go behind the column here and pop the airbag pins off. And when I pop the airbag pins off, you can actually see the airbag unit right here. There's a couple safety clips I need to pop off of here. So I'll grab these safety clips and I'll remove those. Now remember, we timed it out, 10 minutes minimum. So now I don't have any charge here. Now I can go here and I can squeeze these little clips. And when I do that, I can unplug it. And on the other side, I can unplug it. Now, if you carry your airbag to a bench, just lay it face side down or face side up here so it's safe. I'm gonna put it right over here on the seat. And then I can come over to our horn. Our horn switch is located right here. Now I can disconnect the wire and just ground it. Remember when you grounded it, it's supposed to beep. So it's working. So that means the wire's good, everything's good. We have a horn switch problem. So what I'm gonna do is I'm gonna go ahead and replace this switch. But when you're working with electrical problems, be patient, gather all your resources. I'll put this one back together, but for now, it's time to say goodbye. So from our garage to your garage, thanks for watching Tech Garage, presented by Advance Auto Parts.